Look at this stuff. Second half of our lesson, dividing rational expressions. Rewrite the problem by multiplying by the reciprocal of the fraction that follows the division sign. The most common error, Justin, that we get on these kind of problems is people flip the wrong one. So here's my general example. 2/3 divided by 1/5 is the same thing as 2/3 times 5/1. People do the wrong thing and they flip the wrong one. So look at 1 versus 2.
It's the exact same.
2/3 times 4/9. Second one, 2/3 divided by 4/9.
Exactly the same.
Well, they're not. The division sign makes it vastly different. The first one, does anything cancel top to bottom?
No.
So that gives you 8/27. The second one, I want you to rewrite physically in your homework. You rewrite it. Then, let's simplify. Now, we're doing all of these without our calculators here. Does anything cancel between 2/3 and 9/4?
3 and 9.
3 and 9. So cross them out, and above and below, write what they cross to. Cross them out, above and below, write what they cross to.
3/2.
Okay, so our answer is 3/2. So you're going to rewrite your division problems today and multiply by the reciprocal. So as we work through those, it should be simple. Thank you.
You're welcome.
Thank you, Mrs. Hockett, for that visit on YouTube. All right, here we go. M minus 3/2, 3 minus m over 6. Do I need to flip anything? No. Now, I need you to remember something, though. Do you remember that 3 minus m is the opposite of m minus 3? Do you remember that idea? So watch what the top becomes. -1 times m minus 3 squared over 12. See, that's why I'm showing this to you. You see the 3 minus m?
Yeah.
You need to realize that fast that 3 minus m is also the opposite of m minus 3. And because I already have an m minus 3 here, writing it in a simpler manner, we'd write it as something squared times the opposite out front.
What? I still have no idea what's going on.
I have a question.
There's an m minus 3.
Yeah.
There's an m minus 3.
Okay.
Whenever we have two things multiplied together that are exactly the same, we write that as that squared. And then we just have to tack on that -1 out front. That's all. John?
We always cross out the opposites and put -1.
If they're above and below. Are these above and below? No. Okay? Now, below this, let me draw a line. We're going to change this problem a little bit. We're going to call this 3b. Exact same problem, except we're going to change this to division.
That makes it.
Okay? And I didn't want to write this one on our type. I wanted to kind of write it second after we looked at the first scenario. Now, whenever you have division, you multiply by what? The reciprocal. Now, these are very different problems, 3a and 3b. Now, m minus 3 and 3 minus m, what do they cancel to? Now they cancel to -1, so cross them out and put a -1 on top and a +1 on the bottom. Well, you don't have -1 over -1, just -1. The 6 and the 2 cancel to 3 and 1. So on the top I have -1 times 3. On the bottom I have 1 times 1. So what is my answer? -3/1, or just -3. So the difference between A and B is drastic. That division causes the whole problem to flip around, cancel, and simplify. So you have to pay attention as you're doing these, Tara, Is it a division problem or a multiplication problem? Because the division ones you're going to flip. The multiplication ones you won't. Josh?
For the top one, do you just multiply them then?
Yeah, we're just multiplying those together. No. M minus 3 times M minus 3 is M minus 3 squared. That's all. It's like saying 4 times 4 is 4 squared. It's just that squared. That's all. Okay, no big deal. All right, here's our next one. The x minus 2 doesn't factor. The 4x doesn't factor. But let's change it to a times sign.
4x over minus 8.
4x minus 8 over x squared. Now, any one of those four factor.
Yeah, factor the 4x minus 8.
Okay, so we factor this 4x minus 8. Ryan, Switek. See that 4 and the 8? It is a difference. But they're not perfect squares, so we look for a GCF. Between the 4 and the 8, what's my GCF, Ryan? All right, 2 is going to be left when I take out that 4, okay? So you got that 2 there. So we have the 4 times x minus 2. All right? Let's see. I got a 4x there. I got an x minus 2 there. And an x squared there. What cancels?
X minus 2.
All right, that's 1. Justin, anything else cancel?
No.
There's one other thing. Katie? Yeah, the x cancels with the x squared. You see how that has 2x squareds and that's just 1x? So that's x times x and that's just x.
So it's negative 4 over x.
So let's see, what else do we have left?
14 over x.
I've got a 4 and a 4, that's 16.
Never mind.
And I have just an x on the bottom. So Justin, just a little sidebar here. What we had is really x over x squared, which is x over xx. And so that's the idea. That make sense? Uh-huh.
One more question. How would we know why wouldn't we put negative 1 3 minus m squared?
Negative 1. You could have also done that. But generally, you're always going to put the m's first.
Oh, it's not a negative when you cancel?
Okay.
All right, backside. The very first thing you're going to do is change that division problem to a multiplication problem. So there's the very first step as you're working these problems. Just rewrite it as multiplying. Okay, now we factor. The x plus 3 doesn't, the x minus 2 doesn't, the x minus 2 doesn't, but the bottom obviously does. Haley, how's this bottom factor?
2x plus 3.
Okay, 2 times x plus 3. Now do whatever canceling you can. The x minus 2's cancel to 1's. The x plus 3's cancel to 1's. So in this case, I have just 1/2. They're not always going to factor. They're not always going to cancel. But the likelihood that they're going to do that is pretty high. I'm just trying to show you all the different styles that you could bump into. All right, number 6. Let's kind of take this to the next level. If I'm dividing by x minus 3, where's that going to go?
It's over 1.
That's really over 1, so I really have, when I flip it, 1 over x minus 3. Now, look at this top. X squared plus 2x minus 15. What multiplies to negative 15 that adds to positive 2? What's that, John? Negative 3, positive 5. All right, so let's put those in on the top. X minus 3, x plus 5. Look at the other one. What multiplies to 20 that adds to 9?
5 and 4.
5 and 4. So that's x plus 5, x plus 4. Now we look to cancel. Katie, go ahead.
It would be x plus 5 plus 5.
All right, those are gone.
And then x minus 3.
Those are gone. So what's your answer?
And then over x plus 4.
Good. Do you notice how the factors in the bottom always seem to end up in the top and vice versa? So look for that. Say, hey, I already have an x plus 5 in the bottom. What if that's the factor in the top? You know, use that to try to see what they might be. Make it easier on yourself. All right, now here's our last one. What's different about this one? It's a little bit bigger, okay? This top one on the left. The nice thing is that's already factored. And it stays in the same position. Where does this 2x minus 7 go?
To the top.
To the top. Now, the 4x squared minus 12x minus 7, where is that going to end up? Down here, right?
No, it's 14.
So now we have to go off to the side and we have to say, okay, what's 4 times 7?
28.
Negative 28. What does it need to add to? Negative 12. All right, so think with me. Brett, can you think? Factors of negative 28 that add to 12. 2 and negative 14. Okay, so off to the side on the right here, we're going to multiply this out. 4x squared plus 2x minus 14x minus 7. Go to the first two. Brett, keep going. Do my GCF. Not just 2, but 2x. What's left on the inside?
2x plus 4.
Good. 2x plus 1. All right, what's inside my box there, Abby? Nice, negative 7. So 2x minus 7 and 2x plus 1. What do I do with this information? Where's that going to go? In our parentheses? 2x minus 7, 2x plus 1. Are we surprised that those are our factors? Look what's already there. Look at the top. Is there already a 2x minus 7 there? So that kind of indicates to you, Luke, that you're doing the right thing. So cancel out your common factors. Do these two cancel? They're not the same, so they just stay. Boom. I wanted to give you that one because I wanted to show you an example of what happens when it's not just nice, neat x squared. So it all depends. You may have to do some scratch work on the side, so work on the left-hand column for your work and leave the right-hand work for your scratch work in terms of what you're going to work through as we're doing this.